Hello, folks. This is Mr. Dan coming to you from the Landscape Design Classroom, and today I'm going to talk to you about properties of soils. So, all soils not created equal. We have 5 different factors that control soil formation. That's parent material, time, climate, vegetation, and topography. So getting into this, soils are made up of 4 substances. We have small mineral particles in the breakdown of rocks. It's about 45% organic matter, which can be plant and animal material, both dead and living, about 5% of it. And then air and water. So percentages of all water and air vary greatly. Also depending on the soil, how much flow through capacity there is, and what is seeping underneath. So soil textures, you have large particles, stone, cobble, gravel, mineral particles in the soil. These include sand, silt, and clay. And soil texture refers to the amount of sand, silt, and clay in the soil. So if you're looking at clay, you would think that has the largest particles because it's really thick. That actually has the smallest particles, and that's what actually makes it really come together. So how can you tell what soil texture you have? Sand can be seen with the naked eye. Feels gritty. Silt is intermediate in size, visible under microscope. Feels like talcum powder. And clay is the smartest particle. Feels slick and sticky when wet, firm when moist, and hard when dry. The size of particles affect moisture, holding ability, flowering, which crops can be grown. So if you ever drive by a cornfield and you see everything plowed up and there's like some really big like piles that are kind of like a yellowish tan color, that's probably clay. So the arrangement and properties of various soil layers. So you have topsoil, subsoil, and parent material. Surface top layer soil from a few inches to several feet thick. Darker contains organic matter. Softer, more easily worked than underlying areas. And it's also called the A horizon. So if you have if you're in a neighborhood and you start digging down in the soil, typically you're going to find anywhere between 4 and 6 inches of soil. So what a lot of contracting companies will do now is they'll strip that layer of topsoil and resell it, leaving a few inches on top of the ground. But if you're putting a new lawn in, you want to make sure that you want to try to make sure that topsoil layer is about 6 inches deep so you can get a nice thick layer on there. So the subsoil, that's the layer just under the topsoil. It's lighter in color, maybe red, brown, yellow, or gray. Little or no organic matter, usually higher in clay content in subsoil or topsoil, and firmer, more difficult to penetrate. And this is also called the B horizon. So you have the A horizon, which is topsoil, and the B horizon, which is subsoil. And then parent material, the lower soil layer, material from which topsoil and subsoil were developed. Very firm and difficult for roots to penetrate. And it's also called the C horizon. So you have all 3 layers there. You have your topsoil, your subsoil, and then your parent material. Typically plants that can get down in there have a very deep taproot. So this would be something more like one of your yew plants, which can grow about 30 feet deep in some cases. So what does soil color indicate? Brown or dark surface soil layers indicate the presence of organic matter. So organic matter is a good thing. If you see worms crawling around in it and it's very nice, like soft, rich loam, then it's probably really good soil. Subsoils are often reddish brown, red, yellowish brown, indicating how wet it is at certain times. So if you dig down deep and you're starting to get like that gray, mushy stuff, that's definitely in your subsoil layer. Gray means the soil is often wet during the warm part of the year and poorly drained, so you have water holding down in there. And red, brown, or yellow colors indicate the soil is not often saturated with water and is well drained. So the total depth of topsoil, subsoil, and parent material, which will allow growth of plant roots, can cause the yield of a crop to be high or low. Deep-rooted plants such as alfalfa will not grow well when planted on a shallow soil. So deep soil is 35 inches or more in depth, and that's including all 3 layers. Moderately deep soil is 20 to 34 inches in depth, and shallow is about 10 to 20 inches deep. So if you're in a neighborhood, like a suburban neighborhood or whatever, you're probably going to find about 10 to 20 inches deep because, like I was saying before, a lot of that land gets stripped off and it's resold as topsoil. So very shallow soils, 10 inches or less. You could also find this in a lot of neighborhoods as well. So soil-water relationships, the size, shape, and arrangement of soil particles and the associated voids determine the ability of a soil to retain water. So if you have a lot of one thing compared to another, you might have more water in that soil. So if you have a lot of clay, you're going to have a lot of water laying on top of that because clay is very hard to get through. Large pores in the soil can conduct more water more rapidly than fine pores. Sandy soils are going to drain faster because they're a really grainy, large particle in the soil that you can see. And then clay soils are going to retain your water longer. So soil pH, we've gone over this before. Your acidic soils are going to be in the 1 to 6 range, your neutral 7, and your alkalines are 8 to 14. Most of the time you want to keep that, especially for plants, you want to keep that neutral to slightly acidic. So if you're in like that 5.5 to 7 range, you're probably going to be doing pretty well. So water in soil contains dissolved mineral salts, the soil solution. Numbers from 1 to 14 measured with a pH meter. And some materials added to soil change the pH. This could be peat moss is more acidic, and limestone will make it more alkaline. So cation exchange capacity, this is the total number of exchangeable cations a soil can hold. The amount of its negative charge is called its cation exchange capacity, or CEC. The higher a soil's CEC, the more cations it can retain. The CEC depends on amounts and kinds of clay and organic matter present. CEC increases as organic matter decreases. So organic matter. Soil organic matter consists of plant and animal residues in various stages of this decay. The 4 benefits of organic matter: it improves physical condition and structure, increases water infiltration or flow through capacity, decreases erosion losses, and supplies plant nutrients. Decomposition may immobilize some nitrogen. So 1965 oil taxonomy system for the United States. We have gelisols, histosols. I'm going to go through these quickly and you can review these in the PowerPoint attached to your Canvas account. Spotosols, andisols, oxisols, vertisols, aerosols, butasols, mollisols, alphasols, inceptisols, entisols, and just wrapping it all up, soil is the soft outer covering of the earth, one of our most important natural resources necessary for plants to grow, provides food for plants, which in turn furnish food for humans and animals, and stores much of the waters that plants use. So remember, at the end of the day, soils is one of the biggest parts of making sure your plants, turf, pretty much anything is successful in terms of growing. So that is the end of my presentation. If you have any questions, please contact me down in the landscape design classroom, and have a great day, folks.